Okay, factoring polynomials. I think we just did mostly squares and cubes. So this first one, it's a quadratic, but it is not, neither 20 nor 125 is a perfect square. So your first move, see if you can factor out something they've got in common. 20 and 125, if we divide them both by 5, we can rewrite this as 5 times 4b squared minus 25. Okay, now that's going to be better because that's a perfect square and that's a perfect square. So let's write 5, and if you factor down 4b squared minus 25, take the square root of 4b, that's going to be 2b and 2b. Take the square root of 25, that's going to be 5 and 5. But it's got a times and give you negative 25, so one's a plus, one's a minus. And because one's a plus and one's a minus, there will be no middle term. Like this one down here's got a middle term. They're going to zero out. Because when you distribute, you'll have a negative 10b, and this is a positive 10b, and then those zero out. So this is your answer if you factor it. So try and see if you can factor out something they've got in common. Okay, this one, the 3 tells you it's a cube, and there's nothing, no other variables to factor out. So this is going to be a cube. 125 is a cube, and 216 is a cube. So first you need to recognize this as 5 cubed, m cubed, plus 6 cubed. So they're all perfect cubes. Okay, now cubes are pretty easy. It's the sum of cubes. So you're going to take the base, which is 5m, and you're going to take this base, which is 6. Then in your second group, you just take this base and you square it. So 5m times 5m, so that's 25m squared. And now you got to subtract. You times the two bases together. 5m times 6 is going to be 30m. And then you square the last base, so 36. And that is your answer. Okay, this one right here, 20, 100, 125, we can divide them all, first move, divide them all by 5. So if you factor a 5 out of each of them, it's going to be 5 times 4v squared plus 20v plus 25. Okay, now it's going to be similar to this one right here. That's a perfect square and that's a perfect square, but this time we've got something in the middle. So 5 square root of 4v is 2v. 2v square root of 25 is going to be 5. And then because it's a middle and it's a plus, we're going to go plus plus. And they're getting the 20. They times 2 times 5, and that's a 10v, and they times this 5 to that 2v, and that's another 10v, and there's your 20v. So squares and cubes. So this last one, it's going to be a square. 8, 8, and 2. Let's divide them all by 2. So if you factor a 2 out, it's going to be 2 times the quantity 4x squared minus 4x plus 1. That's a perfect square. That's a perfect square. So we got 2 square root of 4x squared, that's going to be 2x, and 2x squared of 1, that's going to be 1 and 1. And because my middle is a minus, I'm going to subtract them. And so your answer, if you write it as a perfect square, it's just 2 times 2x minus 1 squared. And that is your perfect square. Okay, we've got another cube. 16 though is not a cube, and neither is 2. But if you divide them both by 2, it's going to be 2 times 8x cubed minus 1. Okay, now those are both cubes, so let's see what the bases are. The bases are going to be 2 cubed x cubed minus 1 cubed, because 1 cubed is just 1. Okay, now it's subtracting cubes. So it's going to be 2. The first base, 2x, subtract the second base. The first base squared, 2x times 2x is 4x squared, plus times the bases together, 2x times 1 is 2x, and then plus the last base squared, 1 squared is just 1. Okay, that's it. This one, a quartic, so degree 4, and this is actually, this starts with the perfect square, and that's a perfect square. So if you take the square root of x to the fourth, that is going to be x squared. And if you take the square root of 625, what is that? Is that 25? That's going to be 25. So 25, 25. And because it's a minus 625, one's got to be plus, one's got to be minus. And there's no middle term because when you add them up, they're going to zero out. But you can go one step further. This is also a perfect square. So it's a perfect square within a perfect square. That's a perfect square, that's a perfect square. And because it's a minus, they're going to be conjugates. X minus 5 times x plus 5. So you can keep breaking it down. And if you times them forward, that's going to give you x squared minus 25. This one though, x squared, that's a perfect square, but that's a perfect square. But because it's a plus, there's no way to factor. You can't break it down. It's done. Because if you go x plus 5 times x plus 5, that'll give you x squared plus 5x plus 5x plus 25. And it's going to give you a middle. You're going to have x squared plus 10x plus 25. But you can have no middle. You just have x squared and a 25. So the only way you can zero out a middle is if one of them is a minus and one of them is a plus. So this one's done, but this one will break down. So that is your final and best answer. Okay, this next problem, they give you a model, a formula that has something to do with parasites over parasites, the number of parasites versus days, time in days. So they want you to figure out when it's going to equal 0. So you're going to have, I'm changing them to x's, x cubed plus 5x squared minus 4x minus 20. They want to know when that's going to equal 0. And they want you to group them. So I'm going to group these two together. And I'm going to divide both of them by x squared. So it's going to be x squared times x plus 5. And if I group this second group, I'm going to divide them both by a negative 4. So it's going to be negative 4 times x plus 5. So now if we group them, now each of the groups have an x plus 5. So x plus 5. And then this other one is going to have x squared minus 4. But this x squared minus 4 is not done. That's a difference of squares. So my final answer, I'm going to have an x plus a 5. X squared minus 4, that's going to break down to x plus 2 times x minus 2. So there we go. It's a cubic, so there's going to be 3 times where it's going to equal 0. It's going to equal 0 at negative 5, negative 2, and a positive 2. And these are x's, which are really t's, which are days. So at day, negative 5, at day, negative 2, and at day 2, that population is going to equal 0. So that's kind of the answer to B. And C, well, which ones are unreasonable? And the negative days are unreasonable because there's really no such thing as negative days. So the answer you're going to submit to your boss is at day 2. At day 2, that population will be zeroed out. Okay, now, roots. I give you the roots, you give me the function. So a double root of 1, that means you have a root at 1 and a root at 1. So it's going to be x minus 1 times x minus 1. And a double root of negative 5. So it's going to be x plus 5 times x plus 5. And double roots, this is a double root. This will give you double root. Perfect squares give you double root. X squared plus 6x plus 9. If you factor this, this will give you a double root. So it's a perfect square. It's going to be x plus 3 times x plus 3. Because 3 times 3 is 9, 3 plus 3 is 6. So your roots are going to be a negative 3 and a negative 3. But you just really turn in one of them, because it's the same thing. So that's called a double root. Perfect squares are double roots. So they're giving you the double root. They want you to work backwards and write the polynomial. Okay, so now times these through. Distribute it through, or you do them in your head. That's going to be x squared minus 2x plus 1. And this one is going to be x squared plus 10x plus 25. Okay, now it's going to be a little more work. You got to times this to this, this to this, and this to this. So I'm going to x squared to x squared, that's x to the 4. X squared to 10x, that's going to be plus 10x cubed. X squared to 25, that's 25x squared. Okay. Negative 2x to x squared is going to be a negative 2x cubed minus 20x squared minus 50x. And then the last one, 1 times x squared is x squared, 1 times 10x is plus 10x, and 1 times 25 is plus 25. So I kind of stacked them like terms so I can add them up. That's the only fourth. There's a couple cubes. So 10 cubes, negative 2 cubes, that's going to be 8 cubes. There's a few quadratics. 25 minus 20 plus 1. So that's going to be 5. That's 6 squares. And then your x's, there's going to be minus 40 x's plus 25. Okay. Now you're given the polynomial and one of its factors. Find the remaining. So if I give you 12 and I tell you its factor is 4, what is the other factor? Or 4 times what is 12? So what you're doing is you're dividing 12 by 4. You need to come up with the missing factor is 3. So same thing. You need to divide this by x plus 2. And because that starts with a 1, I can use synthetic division. Synthetic division, in this box, I'm not going to put a 2, I'm going to put a minus 2. Okay, now I'm going to put a 1, a negative 1, a negative 10, and a negative 8. Okay, now bring this guy down. That's a 1. Negative 2 times 1 is a negative 2. Add them up. Negative 1, negative 2 is a negative 3. Times them. That's a positive 6. Add them up. That's a negative 4. Times them. That's a positive 8. So my remainder, I've got 0 remainders. So my factors are x plus 2 times 1x squared minus 3x. I guess that's minus 4. So those are my two factors, but the question is, can I factor this down? Always ask yourself, can I keep going? Never ends. X squared minus 3x minus 4, yes you can. So x plus 2 is what they gave you, and you're going to factor x squared minus 3x minus 4 into x and x minus 4 plus 1. Because a minus 4 times 1 is a negative 4, and a minus 4 plus 1 is a negative 3. So that is your ultimate answer. Okay, the next one, because it starts with a 2, you can't really use synthetic division, so you're going to have to divide it out the long way, the old long division. 2x plus 1. And I'm going to put 18x cubed plus 9x squared minus 2x minus 1. Okay, now you just focus really on the 2x. 2x times what is 18x cubed? And it's going to be 9x squared So now 9x squared times 2x, that's going to be 18x cubed, and 9x squared times 1 is 9x squared. Now you got to subtract them, minus that, and you got to minus that. Those zero out, and these zero out too. So bring down your next one, a negative 2x. So what can you times 2x by to turn it into a negative 2x? And then ask what times 2x is going to give you negative 2x? And it should just be a negative 1. A negative 1 times 2x is a negative 2x. But you got to times it to the both of them. You need to distribute it. So bring this one down. Now you're going to have to subtract them. So change that sign, and everything zeroes out, so there's no remainders. So 9x squared minus 1, but you should realize they're both squares. So it's going to be 3x plus 1 and 3x minus 1. So if you divide it, that's what you get. Okay. So same type of question. The volume of a pool is this. So volume is like the length times width times height. And they're going to give you one of them. They're going to give you the height, the depth. So you're going to have to do the volume, 2x cubed minus 9x squared plus 7x plus 6, and you're going to have to divide it by the height, 2x plus 1, and that will give you the remaining factors. So 2x times what is 2x cubed? That's just going to be an x squared. X squared times 2x is going to be 2x cubed. X squared times 1 is going to be 1x squared. Minus them, minus that, minus that. Those zero out. That's a negative 10x squared. Bring down the 7x. What can you times 2x by to turn it to a negative 10x squared? You got times by a negative 5x. Negative 5x times 2x is negative 10x squared. Negative 5x times 1 is negative 5x. Change the signs. Add them up. That's 0. 7x, 5x, that's 12x. Bring down the 6. 2x times 1 is 12x, and that's going to be 6. 6 times 2x is 12x. 6 times 1 is 6. Change the signs. Add them up. They both zero out, so there's no remainders. So x squared minus 5x plus 6 is what you get. The question is, can you factor that? And yes, you can. X minus 2 minus 3. Because negative 2 times negative 3 is positive 6. Negative 2 plus negative 3 is negative 5. So this is like this 2x plus 1 is the height, this is the length, and this is the width. Okay, next one's, if I give you a cubic, so cubic is going to be degree 3, there's going to be 3 answers. So your 3 answers could be this: real, real, real. Or it could be real, imaginary, imaginary. It cannot be imaginary, real, real, because your imaginaries have to come in pairs. And it cannot be imaginary, imaginary, imaginary. So these two are not options. So the number of real roots, you can either have all 3, or you can just have 1. Okay, degree 6, so it can be real, 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 real. You can have 6 reals. Or you can have 4 reals and 2 imaginaries, so 4 reals. Or you could have 2 reals and 4 imaginaries. Or you could have 0 reals and all imaginaries. So you gotta remember, your imaginaries come in pairs, they come in conjugate pairs. Okay. Okay, solve each equation. So find the roots. The roots are zeros, so make these equal 0. So I'm going to bring, if you bring the 46 over, that's the same as 4m squared plus 48 equals 0. Okay, now look at this, let's do this bottom one first. If you bring this guy over, that's going to be n squared minus 10m plus 24 equals 0. And you can factor this. So what times this gives you 24 adds and gives you negative 10. So it's going to be n minus 6 minus 4. So your roots, your zeros are going to happen at 6 and 4. So you need to be able to do that, which is pretty slick. Hopefully we did a bunch last year. Same here. Let's move this one over. It's going to be x squared plus 2x minus 1, and it's going to equal 0. So can you factor that? What times this gives you negative 1 adds and gives you 2. Oh no, it's not negative 1. If you plus 1 and plus 1 here, that should be a plus 1. So it's got times give you 1, add and give you 2. So x plus 1, x plus 1. And this is the double root we talked about. That's x. Your root is just a negative 1. Okay, so these other ones, these top two I think are the same. The top two, you're missing, so in your quadratic, ax squared plus bx plus c, you're missing this. I've got a quadratic piece and I've got a number. I don't have any x's, and this is kind of an easy way to do it if you don't have any x's. Let's just solve for m. So if you do not have any linear pieces, this is probably the route to go. I'm just going to solve for m. I'm going to ditch the 2, ditch the 4, ditch the 48. So I'm going to ditch the 48 first. Minus 48 minus 48. So 4m squared equals a minus 48. Ditch the 4 next. Divide by 4, divide by 4. M squared equals negative 12. Okay, now you got to ditch the square. So you got square root, and you got square root. Anytime you do a square root, you got to account for both the plus and the minus. And this negative, you can never have the square root of a negative. So that is the same as square root of a negative 1 times square root of 12, and this is imaginary. So you're going to have m equals plus or minus the square root of 12, but it's going to be imaginary. And now 12, let's see if there's any squares in 12. 12 is a 3 and a 4 and a 2 and a 2. So square root of 12 is the 3 times 2 squared. And you're going to pull this square out. So square root of 12 is the same thing as 2 times the square root of 3. So your final answer is going to be m equals plus or minus 2 imaginaries times the square root of 3. Your answer's got to be imaginary. Anytime you take the square root of a negative, it's going to be imaginary. Okay, this next one. So there's a square and there's a number and there's a number. There's no x's, no linear pieces, so I'm going to move this over here. 2r squared equals a minus 14, divide by 2, divide by 2. R squared is a minus 7, square root. R equals plus or minus square root of 7, imaginaries. Because the negative, square root of a negative is imaginary. 7, there's nothing in 7, you're done. No squares in 7. Okay, let's go backwards. Here are the zeros. You give me the polynomial. So negative 4 is a 0. That means this got to be x plus 4, because that will give me a 0, times x plus 3 times x minus 5. So times these, x squared plus 7x plus 12. Then you got to times that by x minus 5. So it's going to be x cubed minus 5x squared plus 7x squared minus 35x. 12 times x is plus 12x. 12 times minus 5 is a minus 60. So to apply your like terms, you're going to have x cubed. Your squares, you're just going to have 2x squares your x's, you're going to have a negative, what is that, 23. X is minus 60. And that is it. That's the polynomial that will give you, and so it's cubic, there's going to be 3 roots, negative 4, negative 3, and 5. Okay, this one, they give you negative 1, and 2i, but they did not give you a negative 2i. So your imaginaries have to come in pairs, and then they're conjugates. So negative 1, negative 1. That's going to be x plus 1 times x plus 1. You can do it in your head, that's x squared plus 2x plus 1. Okay, 2i and a negative 2i, so that's going to be x minus 2i times x plus 2i. And if you distribute it through, x times x is x squared. X times a plus 2i is a plus 2i x. A minus 2i times x is a minus 2i x, and these zero out. And a minus 2i times 2i is a minus 4i squared. And an I squared is a negative 1, so it's really a negative 4 times negative 1, which is really x squared plus 4. So you need to times this mess by x squared plus 4. Now you're going to distribute through x squared times x squared is x to the 4, x squared times 2x is 2x cubed, x squared times 1 is plus x squared, 4 times x squared is 4x squared, 4 times 2x is 8x, 4 times 1 is 4. Add up your like terms and it's x to the 4th plus 2x cubed plus 5x squared plus 8x plus 4. So there's a lot of terms. Okay. We might make it. Okay, sketch a graph if it has 3 real zeros and 2 imaginary zeros. Okay, your real zeros happen right here. So there is a real 0 and there is a real 0, so it's going to have 3. So there's the third. Okay, the imaginary zeros are going to be like right here. It's going to come down, it's going to turn around and come down again, but it's never going to cross this x-axis. So that's one, and then maybe that's one. So it never comes back down and touches the 0. And that is 2 imaginaries right here. 4 real zeros. If it's got 4 real zeros, that means it's going to cross 1, 2, 3, 4 times. 1, 2, 3, 4 real zeros. 2 imaginary zeros. So it's going to come down and it's not going to cross. So there's one. Then it's going to come down again and it's not going to touch. There's another one right there. So 2 imaginary zeros. Okay, now compositions. This is F, this is G, this is H. You need to take 1, plug it into G. So 1 goes into G. 1 plus 4, 1 plus 4. The answer is 5. You need to take that answer, plug it into F. Take 5, plug it into F. 3 times 5, you should end up at 15. If you take negative 3 and substitute it into H, negative 3 squared is negative 3 times negative 3, that's 9 minus 1, that's going to give you 8. Now you need to take 8 and plug it into G. 8 plus 4, you should end up with 12. Okay, looking at graphs, this blue graph is F, the red graph is G. Take 2 and plug it into F. Here's how you do that. 2 is your X, this is your X-axis. Okay, F is the blue one, so I'm going to come over to 2 and I'm going to go up until I touch the blue. 2 gives me a 5. Okay, so 2 gives you a 5 and that dot is right there. But now you need to take the 5 and you need to plug the 5 into G. So now go over 5, and G is the red one, and it's going to touch it right there at 2. So your answer is 2. Okay, now take 0, plug it into F. So if I plug 0 into F, 0 to F gives me 1. Take that answer, plug it into F. 1, come over 1, plug it into F, that gives you a 3. Take that answer, plug it into F. Take 3, plug it in, that gives you a 7. 7's your answer. Now take 5, plug it into G. So come over to 5, that's going to give you a 2. Now take 2 and plug it into F. So come over at 2 and it's going to hit at 5. Now take 5 and plug it into G. So I think that's right back where we started. 5 plugged into G gives me a 2. And negative 1. If you plug negative 1 into F, F is the blue line, so come over to negative 1 and then go down till you touch it. It gives me a negative 1. So negative 1, plug it into F. And if I keep doing that a million times, negative 1 is always going to give me a negative 1. So no matter how many times I do it, it's going to give me negative 1. Okay, last one. You need to add them, subtract them, times, and divide them. If you add them, just add your like terms. So that's going to be a negative 2 and 5x's. If you subtract them, you got to do F, 3x plus 1, subtract G. So that's 2x minus 3. You got to subtract both of them. You got to subtract this guy and this guy. So you need to distribute the negative to both. So 3x take away 2x is 1x. 1 take away a negative 3 is 4. If you times them, 3x plus 1 times 2x minus 3, you got to distribute. That's going to give you 6x squared minus 9x plus 2x minus 3, 6x squared minus 7x minus 3. And if you divide them, just make sure you get the right one on top. F goes on top, so 3x plus 1 on top. G is on bottom, 2x minus 3. Just leave it. Don't divide it. Leave it good. The only thing is x can never, ever, ever be something that's going to give you a 0. So 2x minus 3 equals 0. 2x equals 3. Divide by 2, divide by 2. X can never, ever, ever equal 3 halves, because that will give you 0. Okay, last one. You need to create two functions that when you compose them, the answer, when you plug in a 4, it gives you a 0. So here we go. 4 goes into G. Take that answer, plug it into F, it's going to give you 0. T Love says hi. Keith Walker says he's going to ace this test. Here we go. So there's more than one right answer. There's millions of answers. If you say G of X equals, if you write, yeah, you guys go get your headphones. If you write X plus 2, now watch, you can take this 4 and you're going to plug it into G. So 4 plus 2, that's going to give you a 6. And you got to end up a 0. So your rule of F has got to be something like this. Whatever you plug in, you need to take away 6. So now if I take this 6 and I plug it into F, 6 take away 6 is 0. So G could be X plus 2. F could be X minus 6. And that'll work. If I plug 4 in, it gives me 6. Then I plug 6 in, it gives me 0.